This is another example of a limit that we looked at very early on in the school year. At that point, what we did is we came up with a trick, and we said if we divide everything by n squared, we end up with 3 plus 1 over n squared over 6 plus 5 over n. The 1 over n squared and the 5 over n go to 0 as n goes to infinity, so we end up with 3 over 6, which is 1/2. And then we said, because of that, anytime the power on top is the same as the power on the bottom, we can just divide the leading coefficients. L'Hopital's rule actually gives us a good way of... So L'Hopital's rule works about as efficiently, actually not quite as efficient as that trick, but it also works in more general situations than just a rational function with a polynomial divided by a polynomial. So what we're going to do here to use L'Hopital's rule, first of all, let's confirm. As n goes to infinity, 3n squared is going to go to... If I square infinity, what do I get? Infinity, right? So the n squared part is going to go to infinity, which means the entire top goes to infinity. And on the bottom, the n squared goes to infinity, and the n goes to infinity, so the whole thing is going to go to infinity. We only really know that because we're adding them. If we were subtracting, we may have to make an adjustment, although it's going to go to whatever the highest power does. So if we had like 6n squared minus 5n, it still goes to infinity because the highest power goes to infinity. So since it's infinity over infinity, we have that indeterminate form, so we can take the limit as n approaches infinity of, what's the derivative of the top? 6n. What's the derivative of the bottom? 12n plus 5. The problem we have here is that this quotient still approaches infinity over infinity, because we have 6 times infinity on top and 12 times infinity on the bottom, so we do it again. And when we take the derivative of 6n, we get 6. When we take the derivative of 12n, we get 12. We get 6 over 12, which is 1/2. Again, this method actually isn't quite as efficient as that trick that we came up with earlier in the year, but it does allow us to work with more general situations where it's not necessarily just a polynomial divided by a polynomial. And it does give us the same answer here. There will be problems that I'll ask you to do, like this, that I'm going to ask you to use L'Hopital's rule, even though you don't necessarily have to.